All right, so today what we're talking about are whether or not something is a function or a non-function. Okay, so first off, you got to know what a function is. A function is a special relation. Now, a relation is just a set of ordered pairs. That's all it is. Okay, it's a list of ordered pairs. A special relation is in which each element of domain X. Okay, so now I'm giving you another way that we call X's. So they got all these different names that we call X's. So domain X is paired with exactly one element of the range Y. So now you have domain for X, range for Y. Well, here's a little setup of the different names that they call X, the different names that they call Y. Okay, so X's are independent, domain, and input. Okay? Y's are dependent, range, and output, and you got to memorize these. They all mean the same thing, the X and the Y. Okay? So these are the X's, these are the Y's. You have to memorize those. Okay? It just makes everything so much easier when you have those memorized. Now, okay, again, a function, a special relation in which each element of domain is paired with exactly one element of the range, the Y. All right, so here we have this set up, and now you're going to see these set up differently. And remember, these are just ordered pairs. Okay, X and Y, and the 2 and the 4 are an ordered pair. They go together. Okay, the 4 and the 8, they're an ordered pair. They go together. Now this, the way it's set up here, this is a function because each X goes with exactly one Y. All right, the X goes with one Y. But now look at this. This function, the moment that I do this, now wait, the 2 goes with the 4, but the 4 goes with the 8 and the 9. This is no longer a function, okay? Because now one of your X's goes with 2 Y's, okay? So this doesn't work. But now, what if we did this? We changed this and we said, well, that's still a function because each X only has one Y. Even though that this X here goes to the same Y, that doesn't matter. We only care when the X goes to 2 Y's. Okay, so here, function. Okay, everybody good there? That's a function, but whenever you change this, non-function. That's what you're looking at. Okay? So be careful when you see these and understand what you're looking at. Each X can go to exactly one Y. That's what you're looking for. Now, when you see functions and when you talk about functions, oftentimes you talk about what's called the function machine. All right, so here we have a function machine. And you guys should have seen this back in grade school. I don't know, 5th, 6th grade. I don't know when they did this. But sometime in there, where they said, oh, well, you input your X and output comes your Y. This is literally a function machine. Okay, and normally they'll say, oh, use this list of X's. Okay, well, as you put in or input your X, you will only get out one Y. If you get out multiple Y's, it is no longer a function. So they use this function machine to show this. And then they give you this little expression in here and tell you what you're going to get out. Okay, so as I put it in, I only get one out. Okay, and you're going to see this moving forward different ways. It won't look like this, but it'll be the same thing. It's very straightforward, and I keep getting feedback. It's very straightforward, but it's really, I mean, it's good to see and it's good to understand, help you understand what the function is and how they look. Okay, one X gets out one Y, and that's what we're looking for here. Okay, so remember, function, for every X you put in, you only get out one Y. So let's look and see what are we talking about as far as our work that it's going to look like. Okay, well, they're going to ask us, is this relation, our set of ordered pairs, relation, set of ordered pairs, you guys know I'm big on the vocabulary because, well, if you don't understand what we're talking about, it's hard to do the work. Okay, so is this relation, this set of ordered pairs, a function? Is it a special relation where there's only one x for where each x has exactly one y? Okay, so let's look. Well, 0, 0, 3, negative 10, negative 2, 2, negative 6, 4. All right, so my x's don't repeat, so this is a function. Yes. Okay, and hit that, and we're good there. But now, let's come down here and let's say why. Why is this a function? So basically, they're asking you to apply the definition to this. Now, let's read it. There is at least one domain value that has more than one range value. Well, domain is your x, range is your y. Now look, they're using these different terms in here, so you've got to know domain is your x, range is your y. Because if you don't know that, you're going to be looking going, yeah, that sounds good. Well, no, that's wrong. Okay, so it's not that one. Each x value is associated with only one y value. Oh, I like that one. I like that one. Okay, each x only has one y. That makes it a function. I like that one. But let's check. A domain value is associated with different range values. No, we don't want that. That makes it a non-function. Okay? More than one y value is associated with x value. Now, you see how all three of these, they really say the same thing. Okay? This is different. Makes it easy. Simple. Okay. Now, does the mapping represent a function? Now remember, I just showed this to you. Okay? These are your x's, these are your y's, these are your ordered pairs. Negative 9, negative 6, negative 2, negative 3, negative 2, 2. I'm using my x twice. Well, if I'm using my x twice, that can't be a function. So here, nope, not a function. And then they come down here and they go, hey, why? So apply your definition. Why is this not a function? A domain value is associated with different range values. Kind of like that. Each x value has only one y value paired with it. No, that would make it a function. There's only one y value for each x value. Nope, that makes it a function. Each domain value is mapped to only one. And see how they all say the same thing except for one? Makes it easy. Okay? Now, all right, graphs. To determine if a graph is a function, they have this thing called the vertical line test. Okay? The vertical line test, and let's see here, I think I can use this. All right, so the vertical line test. All you have to do is do a vertical line. And if that line, this, passes through our line that's vertical twice, it is not a function. If it doesn't, it's a function. It's that simple. So look, as I go through here, this thing only passes through my vertical line once. So as I go through, it only passes through in one spot at any point in time. That means it's a function. So there you go. Is it a function? Yes, that is a function. And then I bet they ask why. All right, well, same thing. Each x value has no more than one value paired with it. There's at least one vertical line that contains more than one ordered pair from the relation. Now here they're referencing that vertical line test that I just talked about. Okay, well, no, that line only passed through our vertical line once. Okay, there's an input value that corresponds with more than one output value. Input, output. So now they're talking about input and output. So you got to know independent, dependent, domain, range, input, output. Okay, the relation fails the vertical line test. Ah, right there, vertical line test. Okay, leaves me just there. Okay, I mean, and then we're back to here. Does the relation show y is a function of x? I mean, guys, that's really what we're talking about here. I want to go back, see if they do the vertical line again. Yeah, okay, perfect, perfect. Here we go, vertical line. Check this out. As I go through, see how I do my vertical line and it crosses here and it crosses here? That does not pass the vertical line test. Okay, and as I go all the way across, it doesn't pass. It's going through 2 points. Okay, that gives you a good idea of the vertical line test. So this right here is not a function. Okay? Well, why? The relation passes the vertical line test? No, it didn't pass the vertical line test. There's not a vertical line that would contain more than one ordered pair from the relation. There's an input value that corresponds with more than one output value. I believe it is that one. Each x value has no more, yeah, it's got to be that one. Okay? That's all there is to this. All right? Remember, a function, a special, and I'm reading this, a function, a special relation which each element of domain is paired with exactly one element of the range. Okay? Remember, x is your independent, your domain, your input. Your y is your dependent, your range, and your output. Okay? You have to memorize those. It makes it easier. If you run into any problems, let me know.